So today we move into a new chapter. We are now officially in Unit 5. So in the last chapter we graphed lines, we looked at equations of lines, and in this chapter we're doing something similar. But in this chapter, instead of just graphing one line, we are going to graph two lines to see where they cross. So a system of equations is what this whole unit is called. A system of equations is a set of two or more equations. So instead of just graphing one line, in this unit we are going to graph two lines. A solution to a system of equations is the ordered pair. An ordered pair looks like this, is an ordered pair where they intersect or cross. It's the ordered pair where the two lines would cross. So there are three things that can happen when we graph two lines. The first type is the most common. So in the first type, I have a line and it crosses another line. So this crosses one time. So this line crosses this line one time right there. So this thing has one solution. That's what's going to happen most often in this chapter. Lines will cross one time, making one solution. So the answer of this question, the solution where they cross, is right here. To get there, it's the ordered pair. 1, 2, 3, 4, 5, 6. And then it goes up 1, 2, 3. 6, 3. It's ugly, but it works. So that's the first thing that could happen. So I have two lines. They cross at one point. That's called one solution. The next thing that could happen is you graph a line and then you graph another line and they never ever touch. They don't touch because it's called parallel. Those are parallel lines. So because these never touch, there is no solution. There is no ordered pair that would make those cross. Like there's no ordered pairs that it would ever cross at. And the reason why they are parallel is because if you graph them, they had the same slope. Like we said in the last chapter, parallel lines have the same slope. Notice, for them to be no solution, they have to be perfect railroad tracks, perfectly parallel. If one bends into the other at all, then that would eventually have a solution. So in order for it to be no solution, they have to be perfectly parallel. Okay? So the third thing that could happen is that you could graph a line, and then when you graph the second line, it sits right on top of your first line. What that means is that those two lines would touch here, and they would touch here, and they would touch here, and they would touch here, 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 here. Every single spot they would touch. So what we do is we call that infinitely many solutions. Infinitely many solutions because they are the same line. They have the same slope. They have the same y-intercept. They're the same line. So in this chapter, when we see that a line and its other line are exactly the same, we'll often abbreviate this type as infinitely many solutions using the letters IMS. Infinitely many solutions. Very easy. Okay? So to figure out where two lines would cross, there are three things that can happen. So in this chapter, this week and next week, we have three methods for solving systems of equations. The first method is what we're doing today and tomorrow. That's called graphing, the most simple method. We're just going to graph the lines and see where they cross. At the end of this week, we're going to do something called substitution, which is just an algebraic way to solve to see where the x and the y would cross. And then next week we'll do my favorite method, which is called elimination. So that's also an algebraic way to see where two lines cross. But again, today we're just doing method 1. So method 1 says solve by graphing. So what we said at the beginning, a system is when we have two or more equations. In this one, we have two equations. So this is a system of equations. Hopefully, at this point, you're good at graphing lines. If you are not, watch closely. So in this first one, we always begin at our y-intercept. Our y-intercept is the constant, typically in the back. So this one, the y-intercept is -1. Then I'm going to move with my slope. My slope is a 3, because it's in front of the x. 3 is the same thing as 3 over 1. So from this dot, I'm going to go 1, 2, 3 over 1. 1, 2, 3 over 1. Same thing in the other direction. 1, 2, 3 over 1. So now I'm going to connect my dots. And that is the equation of my first line. So now in the next line, again, I have a y-intercept. It's the number by itself. It's a +4. My slope is -2, which is the same thing as -2 over 1. Because it's negative, we drop down 2, and the 1 is positive, so we move to the right one. So from my y-intercept, I drop down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and then I connect my dots. Okay? So if you notice, these two cross at this ordered pair right here. So that is the solution. That is the ordered pair where my two lines cross. So the solution, remember when we write an ordered pair, that's the x, so it goes to the right 1, and then it goes up 2. So my solution is 1, 2. So just for this first page, I'm going to show you how to check that to see if it's correct. And then you'll just graph them and find your solution. So to check it, what we're going to do, this is x, this is y. So to check my solution, what I'm going to do is I'm going to go back to the original equation. My original equation said y equals 3x minus 1. My solution says that this here is a solution. This would make this equation true. So what I'm going to do is instead of y, I'm going to plug in what y is. Y is a 2. Equals. In the equation it said 3. Instead of x, in this one I'm having the x is a 1. Because we said x is 1. And in the back there's a -1. So let's see if that's true. Does 2 equal 3 times 1 is 3. 3 minus 1 is 2. Yes. So if I check it, it means I plugged in my x and a y into the original equation. And yeah, 2 equals 2. We're good. So that is the solution of this line. Because when I plugged it in, I got answers that were equal. So I'm going to check the other one as well. So in this one here, it says start with your y. So my y value of my solution is a 2. So y is 2. This equation says -2 times x. Let's see, x is a 1. And then plus 4. Let's see if that's true. 2 equals -2 times 1 is -2. -2 plus 4 is +2. Yep. If the left side equals the right side, it means it worked. It means that 1, 2 was a solution that would make the left side equal the right side. Same thing here. My ordered pairs were 1, 2. So that's how we can check it. We just plug our x and our y back into the original equations to see if the left side equals the right side. And it did, so it works. Let's look at number 2. In number 2, we are ready to graph. To graph, I begin with the number by itself. It's a +1. My slope is 3/4, so it's +3. So up 3 and to the right 4. So from this dot, 1, 2, 3, 1, 2, 3, 4. Same thing other direction. 1, 2, 3, 1, 2, 3, 4. Connect your dots. So that is the first line that I have for number 2. My second line in number 2 starts with a y-intercept of positive 3. My slope is positive 1 and then over 4. So from my dot up 1, 1, 2, 3, 4. Same thing other way. Down 1, 1, 2, 3, 4. My solution is the ordered pair where my 2 lines cross, which was right here. So it went to the right, 1, 2, 3, 4, and then up, 1, 2, 3, 4. So my solution, my ordered pair, is 4, 4. So now you can take that ordered pair, 4, 4, and you can plug it in. Y is 4, X is 4. You can see if the left side would equal the right side. Same thing here. Plug in the X is 4, Y is 4, plug it in. Make sure the left side equals the right side. That's how we can check that our solution is correct. So now I want for you guys to flip to the next page and graph these. So it says solve each system by graphing. So easy. As long as you know how to graph, these will be extremely easy for you. So in number 1, you have a y-intercept. You have a negative slope, so it would be down 5, right 3. Second equation, you have a y-intercept of negative 3 and a slope of positive 1 and over 3. So go ahead and take a couple minutes and you're going to work through graphing these. Your solution is the ordered pair where the 2 lines intersect, where the 2 lines cross. Okay, so go ahead and try numbers 1 through 8. 1 through 8. All of them are in slope-intercept form, which means they're ready to graph. Okay, so once you're ready, let's take a look at the last piece here. So easy. Let's go like this. Okay, so what we have here is we're figuring out what the solution is, but this time instead of from a graph, we're going to get the solution from a table, which is even easier. So what we have is in this picture, we have a y1, and we have a table that holds all of its ordered pairs. So left 2, up 6, 0, 3, 2, 0, 4, negative 3. So that's this line. Then we have another table to represent the other line. So from the graph, I see that they cross right there. So from the graph, I know that the solution is 0, 3. So that's with the graph. But what if you didn't have a graph? So a solution is where a graph is where your 2 lines intersect. We said that in the first page. That's very easy. A solution is where a graph would intersect the 2 lines. A solution on a table is when you have the same ordered pairs. So if we look at this table has 0, 3, and this table also has 0, 3. So therefore the solution is 0, 3. I could have gotten that by looking at the graph, or I could have gotten that by looking at the table. Very easy. So I'll show you one more and then try these last 2. So this one here, again, solution is the ordered pair that would sit on both lines. It would be on both tables. So you just have to kind of hunt for it. So negative 2, 3, nope. Negative 1, 4, nope. 0, 5, nope. 1, 6, nope. Ooh, 2, 7. 2, 7 is on both of those tables. So that is the solution of my 2 equations. Try the same thing for this one here and for this one here. Very easy. So remember, today and tomorrow, we're just talking about looking at two lines and seeing where they cross, or looking at two tables to see where the intersection is, see where the two ordered pairs are the same. So tomorrow we are going to continue in the world of graphing systems, and then the next day we will start solving them algebraically without a graph. Very easy.